Hello friends, welcome to my channel Easy Education. Be smart and fresh. Let us start here the today's subject. We are going to learn what is friction. So we are going to talk about concept of friction, what exactly it is. And I am going to explain you the concepts which will be crystal clear to you. So be sure. Give the attention and keep your pen and paper ready. So let us go ahead and really understand what is friction. And before we get started, I want to just tell you, please concentrate on the subject. So are you ready, guys? Shall we start our golden topic on friction? Alright, let us start. So if I ask you this question, why does the rolling ball stops after some time? So I am very sure all of you are playing soccer and football, right? So when you kick a ball, what do you notice? After some time, the ball automatically comes to stop, even if nobody is stopping it. When the ball is rolling, automatically it comes to stop. Why is it that? I am sure all of you know how the saucer plays when he kicks the ball. What do you notice? Let me ask you another question, right? So I am not going to play the golf or the mini golf because I am not the professional golf player. So when you play the golf, you shot many times. You know this situation happens. If you watch it on television, so again the goal didn't get best to your expectations. And the rolling ball just stops before it doesn't go into the pit and comes to stop. Who stops the ball? How does it stop? Very good. This is friction of the grass surface. Very good. Very good. This is the friction of the grass surface. So guys, I am sure you know this bicycle and you have tried it definitely. So how you have seen the brake of this cycle work? You know, when you apply the brake, when you are riding the cycle, you apply the brakes. You can see the guys, this is the brake. Here, these are the brakes. Can you see this portion? These are rubber pad wheel brakes. And these are disc brakes. Or in four-wheeler, you see how brake works.
Look at this. This motor car wheel is spinning and the brake drum turning with it. A short brake shoe covered with brake material will be used to stop this wheel. Now watch. See how hot the brake shoe gets? And how quickly the brake material is ground away? The brake shoe is lengthened. The brake shoe doesn't get so hot, and the brake material lasts longer. A still longer brake shoe, less heating, less wear. And now, almost half of the drum is covered with friction-producing brake material, and the wheel is brought to a stop with very little heat or wear. It is a simple matter to see that the effectiveness of brakes and their durability depend to a large extent upon the amount of braking material in contact with the revolving brake drum. And the amount of braking material in contact with the brake drum not only depends upon the length and number of the shoes, but upon the diameter and the width of the brake drum. Imagine a Chevrolet brake without articulated brake shoes. A brake which, from all outward appearances, applies plenty of brake material to the brake drum. But notice this. The ends of the brake shoes are fastened to fixed pivots. Watch as they move about these fixed points that the end of the shoe moves farther than the part nearer the pivot. As long as the surface of the brake forms a perfect circle, and as long as the pivot is located in exactly the right place, then all the brake material will contact the brake drum. But you can't use the brakes without making heat, and heat changes the shape of the brake shoe. See, this shoe doesn't fit the drum anymore. The rigid pivot won't let it, so only part of the brake material contacts the brake drum, and the part that does wears down first. When the brake shoe cools off, then here's what you get. Now only the ends of the brake shoes touch the drum, and only parts of the braking material are in contact with the drum. This is a Chevrolet wheel and its large brake drum, 12 inches in diameter. These are Chevrolet brake shoes. Notice how long they are, how much of the inside surface of the brake drum they cover. But even more important, notice how these shoes are supported. Instead of a single pivot for each shoe swings on a link with 2 pivots each. Notice too that each shoe can move as it wants to and should within the circle of the brake drum. There is nothing to prevent each shoe from exactly fitting the brake drum, whether it's hot or cold. Now notice that this simple little piece, as it turns, spreads the outer ends of the shoes apart. As the brake operates, every square inch of braking material hugs the brake drum. Every square inch of braking material wears exactly the same.
How does the matchstick works? If you see, right? You strike the matchstick. All of you might have seen it, right? You might have tried the matchstick on the matchbox. What is the answer to all these questions? That is friction between the matchbox and the matchstick. So, next time, look at it carefully. So, the matchstick and matchbox for the rough surface. It is that friction which generates some heat and causes the matchstick light up. If you watch all these questions, what is the cause of this? What stops the rolling ball? That is the friction. Who stops the bicycle or a four-wheeler? That is friction. What lights up the matchstick? That is the friction. So, one question is, What is the direction of friction? What direction does it acting? So let us try a simple experiment, right? You can do it right now. So you are sitting on a table. Get a book. Now put this book or an object on this table. So you can see the book on the table. Alright? Now let us imagine I try to push this book in this way, or you try to push. So if you try to push the book or the object on the table, you can experience that there is a friction, right? So which way you are applying the force? So let us say you are applying the force. So you are applying the force in this way. Let us say this is your force, and like this the book will stop after some time in this case. Can you tell me what is the direction of the friction? Can you guys? Fantastic. Raju is saying opposite. Lakshmi is telling opposite. Kavita, Dinesh, everybody is telling in opposite. Excellent, guys. So which way I should draw the arrow? You are absolutely right. The force of friction will be opposite. Yes? All of you agree? So everybody agrees with this. Very good. Rather than we say the force is in this way. So if you are applying the force in this way instead of this way, the friction will be in the same way. So if you are applying the force in this way instead of this way, the friction will be in this way. So let us say the force is in this way. Will the direction of friction remain the same? No. It will be exactly in opposite direction. Very good. If you are considering it in the north direction, absolutely telling you guys are right. Friction will be in opposite direction. Friction is also a force, right? And it has a direction. So fantastic. The friction will be in opposite direction. Similarly, if you change the force in this way, so if your force is in this side, what will be the direction of the friction? Opposite direction. Opposite to what? Can you guys tell me? You can say opposite to the force as usually you see in this book. The answer is that is in opposite to the direction of motion. Now the friction is in the opposite to the direction of motion. So do you guys everybody agree? Sometimes there is no motion. Yes? So it is the friction trying to oppose the motion. Yes? Right? Or it is opposing the force. What is the force if the book is moving? Definitely it will be the friction. We can say opposite to the motion. So you can say the force of friction is opposite to the direction of the motion. It is kind of opposing the direction. Do you agree? So if you read definition in your book, it is something like this, right? Opposite to the motion or opposing the motion. So can you say what is friction? Friction is a force, just like you apply the force. Friction is also a force that opposes the motion. Does it help the motion? No. So the friction is like the opposition party of the motion, right? It is always opposing the motion. So in this example, also it is motion of the work. What is the motion of the work? All of you agree that it is towards the hole. So the motion is this way. So the motion is in this way. Yes, this is the direction of motion. And the friction is obviously acting in the opposite direction. So if the golfer hit it, what is the motion of the ball? What do you feel? It is towards the hole. The friction will be in opposite direction. The golfer feels that ball should go into the hole, but it doesn't go. He doesn't blame the force, but he blames to the friction of the force. Here, can you say it is opposing the motion? Do you guys agree? Sometimes friction helps the ball to go into the hole, or sometimes it doesn't help. So it comes in practice. Sometimes it slows down, sometimes the ball goes fast. But in this case, it is stopping the ball because it is opposing the motion, and please remember, friction is also a force. It is not just magical thing. It is force. Friction is also the example of force. It is in the opposite direction, opposing the motion. So if you ask which surface create greater friction, just the common sense and experience. That is right. On which surface it will more? Is it on marble surface or on the road? So what is, guys, do you think? Your answer is right. So which surface has the greater friction? Is it on the marble or the road? Very good. Very good. All of you are giving the correct answer. Road has greater friction because the marble is smooth in comparison with the road. So the road is definitely rough. So from our experience, we know that a rough surface, right? A rough surface causes greater friction. Do you guys agree? And you can try this simple experiment. You take a ball and you roll it on a marble surface. So that is, you have taken the ball and you rolled it on a marble surface. So if you apply the force and you roll it here on the marble, and if you take the same ball and roll it on the road with same force, where it will roll more, which will cause the travel more distance before it's stopping? Can you guys tell me exactly? So from your experience, it is on the marble because marble is slippery. This is why the rough surface has the greater friction compared to the smooth surfaces. So, right? This friction is the force which opposes the motion, right? And it is acting between the two surfaces. So let me ask you, what is the cause of friction? As we saw here, that when you are applying the force on the book, automatically there is a friction. Force is in the opposite direction, opposing the motion of the book. If you apply the less force, the book will not move. Do you guys agree? If you apply too less force, the book doesn't move. So there is no motion. The book will be stagnant. That will be the static friction. There are two types of friction. One is static and the other is kinetic friction. When you apply a force, there will be the friction force in the opposite direction. But what is the cause of this friction? Can anybody tell that how there is the force between the two surfaces? Because ideally we don't want to force on it. If you want to push the book, you want to apply the force. We want the book to move. But this force is always irritating to us. Okay? It is in opposite direction. Why does it act? Exactly, what is the cause of friction? What is the cause here? So all of you are agree that the friction is between the two surfaces. So you need two things for the friction. Will there be the friction only on one thing? Yes or no? No. Absolutely right. So to understand, let us have two kind of. Say this table is a marble table instead of wooden table. There will be the lesser friction. Do you guys agree? If the table was very smooth, and let us, the books sometimes have the laminated cover, then the book is very smooth. So the book is very smooth and the table is also very smooth. There will be less friction. So we wondering why there is the friction. So if you put the book on the road, that they are perfectly smooth. So if they are perfectly smooth, right, there will be no friction. But the reality is it appears to be smooth. So if you look at these two surfaces, right, it appears to be smooth. Let us say this book, it will actually look like something like this. If the surfaces are perfectly smooth, say in ideal case, both are perfectly smooth, will there be friction? No, there will be no friction at all. These surfaces appears to be smooth, but they are not smooth. They are little bit rough. Okay, they are something like this. So I am just drawing it here. Just as a visualization with two eyes, for better understanding you guys, that I am trying to draw the book and table surfaces like this. The book will stop on the table because of the friction. Is it yes or no? Let me share some portion so it will look nice for you. Alright, so in reality it looks like this. Yes, it is looking like teeth. Okay, so very good. What we can see it here, even if it is a smooth surface, you can see the irregularities in two surfaces. There are irregularities of the two surfaces. This is the edge of the book and this is the edge of the table and appears to be smooth, but in reality under microscope you can see it to be rough in reality. So this rough surface causes the friction. It looks like pair of teeth. So all of you, let it will interlock. So there will be interlocking of the two surfaces. So it is the cause of friction. Okay, friction. Interlocking of these two surfaces. Okay, because the interlocking of these two surfaces actually getting locked at the microscopic level. They are getting stuck. So let me guys, by force like this, the book automatically stops. There is a friction on the opposite direction. So there will be the friction force in the opposite direction. So what will be the answer? Irregularities of these two surfaces causes the friction. What do you feel? It is due to the irregularities of the two surfaces. even though the surfaces appear to be smooth. Rough surfaces have more irregularities. So that this session is more informative and helpful to you. Like it, subscribe it, and share it. Thanks for watching.